So suppose in the 2026 QAMT Problem Solving Competition, you get given this problem. What can you do? The Ducci process takes a four-tuple ABCD of digits and replaces it by the four-tuple A minus B, B minus C, C minus D, and D minus A, all in absolute values. The popularity of a four-tuple, XYZW, is defined as the number of different four-tuples ABCD which are mapped to XYZW after applying the Ducci process once. For example, the popularity of 2026 is 0. What is the maximal popularity among all four tuples of digits? So, maybe we should draw a diagram here with A, B, C, D. Think about it. To get from A to B, depending on which one of A and B is bigger, we basically have to add or subtract A minus B. This number, this digit that A gets mapped to after this Ducci process is just the absolute difference between A and B. So depending on which one is bigger, if A is bigger, you have to subtract this difference to get to B. If A is less than B, you add this difference. Okay. And then this is just B minus C. And to get from C to D, you can either add or subtract that. And to get from D to A, you can either add or subtract that. So, what you realize is that after going around the circle once, after starting with A, you're going to get back to A. Which is why we can see that A plus or minus this, plus or minus all of this, gets back to where we are. So that means after taking plus and minus of some of these, we are getting back to where we are. So the sum is 0. So that means out of these four numbers, the sum of the positive ones has to be equal to the sum of the negative ones. And when I say positive, negative, I mean the ones that I take plus and the ones that I take minus here. Okay. So consider these four numbers. What could they possibly be? Well, what happens if all four are 0? Well, their sum is definitely going to be 0. If all four are 0, then that means A, B, C, and D are all equal. So what is the popularity of 0, 0, 0, 0? I'm just going to write pop. It's going to be 10, right? Because 0, 0, 0, 0, 1, 1, 1, 1, all the way up to 9, 9, 9, 9. They all get mapped to 0, 0, 0, 0. Okay. So, what happens if 3 are 0? Because the sum of the four things is 0, then the fourth thing must be 0. Okay. What happens if 2 are 0? When the sum of four things are 0, then maybe they are 0, 0, x and y, x and negative x in some order, right? Now, what does that mean? Well, if two of these, let's say this is 0, this is 0, and then one of them is x and one of them is negative x, what we can see is that A, B, and C are all equal, for example. Only these two are negatives of each other. So what does that mean? Well, if we take x equals to 1, then I guess A, B, C, D, how many choices do we have? We can get 0, 0, 1, 0, right? We can get 1, 1, something 1. There's two choices here because you can put 0 or a 2 there. And then 2, 2, something 2. Again, there's two choices because you can put 1 or a 3 there. And I can keep going up to 8, 8, something 8. And there's two choices here, put 7 or 9, 9. We only have one choice. So there's one choice here and one choice here. So what is the popularity of this particular case where we take x equals 1? So what is the popularity of 0, 0, 1, and 1? Well, 1 up to 8, we've got 16, 17, 18. So the popularity is 18 if I add all of these possibilities together. Can you see what's been happening? I start with 0, 0, 1, 0, and this 1, 1, 0, 1 is my base. And I'm able to take these two, and I can add 1 to them. I can add 2 all the way up to adding 8 to them. So there's 2 times 9 equals 18 possibilities. So basically, I can shift these 4 tuples along the number line and put them in 9 different positions. Now, think if x was any bigger, the range of these numbers is going to get bigger and there's less positions I can put them in because we have to stay with single digits. Okay. Now, what happens if one is 0 and the other 3 are not? For example, if we have 0, A, B, -A, -B, or whatever that is. So, maybe A shouldn't use these variables. X, Y, minus X, minus Y. Minus X, minus Y, whatever that is. So if the absolute value of A minus B is 0, I can still say A equals B. So I guess I can add X and add Y. So C maybe is equal to A plus X, and D is equal to A plus X plus Y, right? Of course, we need to try and reduce X and Y to make this the same, make this popularity greater, because it's going to reduce our range and we can put it on different places on the number line. So what happens here? Maybe giving an example, let's say just 0, 1, 1, -2, or in some order like that. Then I am able to start with 0, 0. So this is what A, B, C, D are. This is X, Y, Z, W. And this is A, B, C, D. Now I have to add 1 and add 1. 0, 0, 1, 2. Right? And then I can do 1, 1, 2, 3, all the way up to 7, 7, 8, 9. But then I can also do the opposite, right? I can go down 1 twice and then go back 2 up. So I've got this choice. So these are the 4 tuples that I can do in that sort of a way. And we've got 2 times 6, 2 times 8, which is 16. Okay, well, when 1 is 0, still, we can't beat 18 here. So maybe none of them are 0. Okay, none of them are 0, then what happens if one of them is X, Y, Z, and then if we have that? Then the most basic example I can think of is 1, 1, 1, -3. Then if we see something like that, then maybe we can have 0, 1, 2, 3, or something like that, going up 3, all the way up to 6, 7, 8, 9. Or we can go like this, but still, that's only 14, right? So if one of them is the sum of the other three, that's not going to give us anything more. So let me just erase that. So the biggest that we can actually get is 18 so far. But there are still some cases that we haven't considered. So if I took x, y, and then let's say minus p minus q, two are positive, two are negative. Oops. X plus y, let's say that that is equal to p plus q. Then I'm able to do a lot more, right? So I can start with a, and then I can go a plus x, a plus x plus y, and then a plus q, right? Because a plus x plus y minus p is just q, and then we're back to a. So my four numbers are like this, but I've also got another way I can go is to go the negative way, right? So I've got two choices here. Right. Is that going to do us any good though? Maybe if this was 1 and this was 3 and this was 2 and 2 or whatever, a plus x plus y is just a plus 4. So this can go from 0 to 4 up to 5 till 9. That's still not enough, right? But what happens if two pairs of these are the same? Like x and p, y and q, they're the same, then that actually gives us the best. Like if we have 1 minus 1, 1 minus 1. What's the popularity of 1, 1, 1, 1, for example? Well, if I go 0, 1, 0, 1, that works, right? And I can add 1 to it, I can add 2 to it, I can just start with from 0 up to 8. There are 8 different choices, right? Maybe if I go 1, 2, 1, 2, and then we get back to 1. 1, 2, 3, 2, I get back to 1. If I do 1, maybe let's not do 1. If we go 2, 3, 4, 3, and then back to 2, that's 4. Difference 1, 2, 3, 2, 3, 2, 1, 2, 3, or even 2, 1, 2, 1. 2, 3, 2, 3, 2, 1, 2, 3, 2, 3, 2, 1, right? And I can still keep going, and I can do 2, 1, 0, 1. All of these, they differ by what? 1. And there's 8 different places where I can put this. I can start this one at 0 all the way up to 7. I can start this one from 0 up to 8. There's 9 choices here. There's 8, and then there's 9 choices for this one. And there's 8, and there's 8. So, what's the popularity of 1, 1, 1, 1, 8, 9, 8, 9, 8, 8? So what's the sum of all of these? I believe this is 50. So the maximum popularity is 50. You can't possibly get any more because you can choose to either go up 1 or down 1. If I made these numbers any bigger, that's not going to be good. And if I made any numbers 0, that's not going to be good either. So the maximal popularity is 50, and we are done.